Hey guys, in this video I'm going to show you how to perform object localization. We're going to be using Google Cloud Platform's AutoML to create a computer vision model that can take a series of images and detect a particular object of interest and return the coordinates of that object within the image. So we can use this for things like cropping an image based on the portrait of a particular person, or just extracting really any arbitrary entity out of an image. So we're going to walk through that in this tutorial. Anyways guys, let's get started. Okay, so just to reiterate, in this tutorial we're going to show you how to use AutoML to create a object localization machine learning model where you can find what you're looking for in an image and extract it or crop it based on the coordinates returned. Usually this is used to find objects, people, places, cars, devices, etc. in images. We're going to be doing something a little bit different. So what we're looking at here is called a medical congress, and essentially it's a aggregation of abstracts, medical abstracts that have been conducted throughout the year that usually relate to a particular field of medicine. And for this particular example here, what we're going to try to do is we're going to try to extract two types of objects, quote unquote. One is figures like this, which are essentially images. Anytime we see an image, we want to be able to extract that. And then also tables, because these are used throughout these abstracts, and we want a way to extract them in an automated fashion. This is currently a PDF file. PDF files are not quite images, but we're going to cast it to an image, and then we're going to do the extraction from there. So we can just kind of assume that this is essentially an image. And for the training data, we're going to use two different types of medical congresses, just so that we end up with a model that isn't overfitting for a particular format of medical congress. Like this one is, it's called US CAP, and then we have another one over here called AACC, and they're syndicated differently and follow different formats. And by providing both of these to our model, we should end up with something a little bit more generic and robust that will generalize across new abstract formats that it's never seen before. But it's the same issue here. Like, we want to extract these images and images like this and tables like this. And we're going to do that in an automated fashion. So the first thing we want to do is we're going to take these two PDF files, convert them to images, and then that's going to be our training data set. And then we will label them, and then we'll run the machine learning model. So let's first convert these to images. So different ways to do that, and based on how you're sourcing your training data set, this step here, this generation of training data will be conducted differently. So don't get hung up on that. Like, you might be downloading your images from Google or some sort of open source collection of images. That's totally fine. I just have a very narrow use case that I want to address here. Actually, this is something I worked on with a client, so that's how it came up. Okay, so I'm on a VM here, which is Linux based. The reason I'm on this is because this is where I'm going to convert those PDF files into images. So I actually have those PDF files already already located on this this VM here. So the first one we want is the US CAP 2019 pancreas, and then the second one is that AACC, which is over here. So they're both here. So so we're going to run that conversion here. So let's start with the pancreas one. Let's make a directory where we're going to house those images. So I'm going to do make dir, and I'm going to do US CAP 2019 training data. And then how we convert the PDF into the images is through a command that I have here, which uses a command line utility called convert. I don't think it's installed on Linux servers out of the box, so you might have to use Package Manager to install convert. It would just be like apt-get install convert, I think, or you can just Google it. Should be pretty easy. But the way this works is we run this command. The first argument is the file, the PDF file, and then the second is going to be the output destination. So the output destination will be relative path. That's our directory. Then you have to give it a generic file name. So let's just do, export.png. Let's do export uscap.png. And this 300 here relates to the resolution. I think 300 is the highest. If we want it to perform faster, we can reduce that number, but the quality will also reduce as we do that. So I'm going to run this, and this will probably take a couple minutes because, let's see here. This is the USCAP PDF. It looks like there's 60 pages, and it's converting each page into an image. So it is, processing graphics. It's writing to disk. It's doing a lot. One little trick that I like to do is when I'm running a command that is potentially a little CPU intensive, I'm just going to open up another terminal here while this one is running that command. You can monitor how a command is affecting the system using something called HTOP. So I can open that up for you guys here. And HTOP, I don't know if it's pre-installed in Linux, but HTOP will show you resource allocation. So yeah, we can see here we have all these commands. These are all processes that are running primarily in the background. But this one here at the top is it's consuming the most resources, and that's the command we just wrote that we just executed. You can see it's that convert density, yada yada. And so we get metrics around the memory utilization. It's at 73%. Well, it's hopping around, but it's in the 70s and the 80s. And then CPU is hopping around, but it's hopping up to 50% at times. And that's because, again, it's processing each page and it's writing each page as an image, and it's iterating over each page. So yeah, we can see it's eating up a bunch of the resources right now, and this just helps us understand, how much load this command is having on the system. And sometimes you don't have enough RAM, and you'll see it at 100%, and that's just good to know. So this command should finish shortly. So we can see in this terminal here the command has finished, and then look at HTOP. You see the command is now gone, and look what happens to CPU and memory utilization. They're freed back up. So it's kind of cool to see that. All right, so let's convert the other PDF file now. So I'm going to do make dir AACC export, and then it's the same command. We're just going to throw the different arguments in there. Let's see here. ./ always means it references the current working directory. whereas just / is what's called an absolute path, and it would start at the root directory. So that's what I'm doing there. All right, so let's do export AACC.png, and let's give that a shot. So now we can see this command's running now, and look, CPU and memory are now being consumed again. All right, so now let's convert this second PDF. So I'm going to do make dir. Let's call it amp export, and then this is our convert command. We're going to do AMP global 2019. And the folder we want it to go into is AMP export. The name will be AMP export.png. Okay, so that second conversion has finished, and I can see all my files are here. So what we want to do now is we want to move these files away from our VM and over into Google storage, Google Cloud Storage. Again, I'm going to use the gcloud gsutil command line utility. If you don't have that on your machine, it's easy to download. And what that lets us do is just easily push and pull assets from cloud storage to our local device. So the way that works is your cloud storage is just a hierarchy of directories. My primary directory here that I want to work out of is called client-work. And then maybe we'll create a subfolder called PDF images. And then we can navigate into that. So that's where I'm going to upload everything. So we want to upload entire directories. So we're going to do gsutil cp -r for recursive, and we're just going to pass the directory. So in this case, it's going to be amp _export, and then the remote destination is always gs:// and then it's that directory, like a directory path that I was just talking about. So client-work, and then PDF-images, and that should upload each image into that directory. So see how it's doing it synchronously here? It's telling me here, it told me that if I use an -m flag, it will upload them in parallel. So actually, let's give that a shot on the other one. So if I refresh this bucket, you see my folders there now. That looks good. Let's upload the other one. So this time it is US cap. Okay, and then I don't know where that -m flag goes. Oh shit. I combined the two flags, and RM actually means delete, so that was not good. Yeah, I'm just trying to figure out where I put that -m flag because I want to try this. Oh, there it is. Yeah, so now it's uploading them in parallel, which I don't know. If you're uploading a ton of images, I guess is advantageous somehow. Anyways, side note, but both of our directories should now be up here. Let's take a look at the images, do a little quality control here. Okay, that looks good to me. check out the other abstract AMP export. Okay, they both look good to me. So this is going to be our training data. So let's now go over to Cloud Vision. So Vision, and then we want AutoML Vision. And then we're going to do new data set. And then let's call this table figure. Actually, we can only do underscores. Table figure extraction. And then we have different model types here. So single label classification would be like just a binary. We look at an image and we determine if it matches some classification. And then multi-label is the same thing, but there's multiple classes. So like for instance, you could have a model that could like look at leaves of plants and like try to categorize what species it is. But we want localization and detection. So we're going to use this one here. Create data set. All right, so this is where things get a tiny bit funky. And I actually think there's a bug with this option of uploading images from your local computer. Every time I do it, I select the directory and then the continue button still stays disabled. So what we're going to do is we're going to opt to reference the images that are already in our Google storage directory. And the way you reference the images is you have to create this CSV file. So it's a little bit of a pain in the neck, but what I'll do is I'll put an example file in the description so you guys can just copy and paste that. And the way it works is you can label each image as either training, validation, test, or also unassigned. Unassigned, if we upload all the images as unassigned, then AutoML is going to do like an 80-10-10 split, and it's going to randomly assign images to one of those training sets. I don't want to do 80-10-10 because you need a baseline number of labeled images in each of the sets, and if we leave it to random assignment, then for every one image we put in the test set, we're gonna have to like label 10 images, and I just don't want to do all that work. We're gonna do more of an even split among these, and then as we label them, they'll fall into the proper sets. We'll meet the criteria, and then we can train the model. So I'll just show you guys how that's done. Also, we are not going to explicitly define any of the like the coordinates around the localizations. We're going to do that within the AutoML UI. So we'll just leave them like this, unlabeled, and that's actually okay. So we just need to come up with a text file here. So what I'm going to do is come back over to my Linux terminal here. So let's get all the image names of the first PDF. So let's do this, ls. So these are all the image names of the AMP Medical Congress. So I'm just going to copy these. I'm going to go over to VS Code. I'm going to paste those in there. And then I'm going to do the same thing for the US cap. How does that happen? Okay, so creating this file, like this is where it can get a little tricky. I use VS Code as a text editor because it has a really good search and replace capability. So I'm hoping we can format this file just using some simple search and replaces. So basically, we need to create the cloud storage path. See how this says gs / and then it has like the folders and all that? We need to create that path for all these images. So the path for the AMP export images is client work, PDF images, AMP export. So to programmatically like preference these, what we want to do is use search and replace. We're going to select regular expression. And the regex is, let's just look for the word amp, right? And then let's replace the word amp with gs / client work / PDF images / amp _ export / and then we also want to replace the word amp. And we want to use the replace all option here. So I think we just set that up correctly. And then we want to do the same thing for the for these exports here. So let's do export US or export US. And then the path on this one is USCAP 2019 training _ data. USCAP 2019 training _ data / and then we also want to replace that prefix. All right. So now these images are all referenced absolutely in the Google storage bucket. So that's good. So now the format of this file is they're all broken out into new lines, and the first column is the label, and then there's a bunch of other columns here. Again, we're going to leave those blank. So let's first just break these out into new lines. So the way we can do that is we can look for gs : and then we can replace it with I believe we can replace it with \n gs : okay. And then maybe we can get rid of these. Oh, maybe because that's regex. So we're just trying to get rid of these some of these like double spaces here, and let's actually do it so it's not just two new lines. There's sometimes a bunch here. So if you do \n plus \n, yeah, that should do the trick. So we're going to replace all those instances with just a single new line. Okay, getting closer, getting warmer here. All right, so now we need to preface with. Actually, let's add the trailing commas first. So we're not going to provide labels. We're going to do that within the UI. So $, will get you end of line. Let's get any spaces before. \s plus, actually we can do star. Yeah, that will get us the end. So we want to replace that with, I believe it's 8 commas. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think that's right. Okay. Okay, so now, all right, so now we want to add on, so now we're gonna label our data. If we wanted to, we could just label it all as unassigned, but again, it's gonna do that 80-10-10 split that we don't quite want. We want more of an even distribution. So this is the start of the line, and then again, we want to replace it with either train, test, or validate. We don't want to do all of them. We want to kind of manually go through here. So I want to get both of the abstracts. So we want sufficient training data, but I also want enough test and validation data. So let's see here. All right, and then let's do test. Oops. Okay, that looks good. And then let's do some validation. The way AutoML does this importing of data is kind of silly in my opinion. There's got to be an easier way, but all right. So and then for these, let's just do unassigned. All right, I think this is going to be, a fine mix. All right, so this is what we're going to do. We're going to go ahead and save this as a CSV file. Okay. All right, so let's try to import that. Hopefully we got it right. Oh, okay, so actually we need to upload that CSV file. So we can just throw that in this directory here. Okay, I'm going to go find it. All right, and let's go ahead and try to import that. So AutoML is going to read the CSV file. It's going to find the location of all those images in Google Storage. It's going to label them based on how we labeled them. And because we provided none of the annotation or boundary boxes, it's going to let us actually define those in the UI. And this is actually, I think, one of the cooler aspects of AutoML is that we can just click and drag in order to label our data. So really, you don't have to write any code, which is pretty impressive. And we shouldn't need much data either. So hopefully we can define this pretty quickly. Okay, so it took a couple minutes to process the data, but it looks like it read the file, and now I'm on the Images tab, and we can see we have 129 images. So this is awesome. We don't need to label all the images. If we want a better model, we can do that, but I just want to provide an example here. So let's actually first create the labels. So the first is going to be image, which is also like a figure, and the second will just be table. And then what we're going to do is we're actually going to go through these and label them. And again, you need a minimum amount of data in order to run the training. So look, each label should have at least 10 bounding boxes, but you need a minimum amount in all three of these categories. So that's why I did the split of, we want more training data, but we need some validation and test data. And I didn't want to do 80 training images just to get 10 validation images. I wanted that split to be a little bit more even so that we can get through this quicker. All right, so let's go through and start labeling some. So if I just double click on the first image here, what I can do is, so this would be an image. So I just dragged this rectangle over this, and we can pick the label we want. In this case, it is an image. And that's all that's on that page, so I'm going to go to the next one. And we're just going to start labeling these. Oops. Let's go ahead and delete that. So table, image. All right, let's take a look and see how we're doing on data. So I'm just going to exit out of this and go over to train. Oh, so we have enough data now. Now we have basically no data. So I wouldn't expect this model to be very good, but like it's suggesting it would like us to have, I don't know if it's 100 or what, but yeah, I mean, we just don't have that much data. So let's do a little bit more, and then we can start the training. Generally, I find AutoML is very good, even on low amounts of data. So for this example, I think we might be able to get away with just a small amount of data there. But let's label a little bit more. So let's go over to unlabeled. All right, let's go ahead and try to train the model based on what we have. Keep in mind we have very, very little data, but I think it might potentially still work. So we're over on the train tab. We're just going to click start training. Okay, so now we can go to train our model. We're going to use cloud hosted. Can optimize for higher accuracy. And this has recently changed. So they charge you for training, and you used to be able to do 1 node hour, and now it looks like you have to do 20 as a minimum. So I would suggest looking at the pricing guide and also use a new free account, because you'll get credits and it'll essentially be free, because each node hour is like a couple dollars. So you do 20 times a couple dollars, you end up like $60. So yeah, use a free account and do 20. And you can do start training. I'm not going to do it here because I don't want to pay that, and I've already done the training. So okay, so yeah, we can go over to the model that I have that's trained. So once the training is complete, you'll get some summary statistics here. And what we'll do is, so now there's a model, but the model's stored in the cloud. So to interface with the model, we need to deploy it. So I'm going to go and click deploy model, and we'll just deploy it on one node rather. And you want to remove the deployment when you're not using it, because you pay per hour. So we want to make sure that we're not paying more than we need to. So to test the model, let's take a US cap Congress that it's never seen before. So let's take this liver US cap Congress. So I'm going to go ahead and download this. And we'll just snap a couple images out of it and use that as some validation data. So yeah, this should be a good one because it has images and tables. Okay, so we have a couple examples from a new Congress that it's never seen before. So we can use that to validate the model. Looks like it's still being deployed here. The model has been deployed, so we can go ahead and test it. So I'm going to upload one of those images that we just created. Alright, so let's do liver example 1. So this just lets us predict from the UI. And you can see here, it's very accurate. So this model has never seen this image, and it's been able to categorize this as an image, this as an image, and this as a table. So that's pretty awesome. Let's run our other example. Perfect. Image, image. And basically, we're interacting with the model in the UI here, but if you can also make REST calls to the model where you pass it either like a base 64 encoded version of the image or a reference to the image in some sort of public hosting like cloud storage or something. And what it's actually returning are the coordinates of these boxes along with the label. And from there, you can do things like cropping or what they're doing here, which is just putting elastic bands around the objects. So really you can do anything you want with it. And what I did with my client was I cropped out the figures in the images and used those, repurposed those for what we were trying to do. So yeah, I mean, you can see AutoML is very good at creating accurate models, even with low volumes of data. As long as there's a fairly intuitive pattern, then it should be able to discern pretty well what your various objects are. And so yeah, that's all I have on this tutorial here. Hope you guys enjoyed it.